I think you're going to find this pretty easy. The Pythagorean identities, there are 3 of them. The one that you are responsible for the regions is this one right here. Sine squared theta plus cosine squared theta equals 1. So basically you have a formula, and all you're really going to do, in this case, they give you a value and you're going to plug that value in and you're going to solve for whatever it is they're asking you to solve for, which in this case they're asking you to solve for cosine theta. So I'm going to start with just rewriting the formula. So sine squared theta plus cosine squared theta equals 1. Now, so we know that the sine of theta is negative radical 2 over 5. But according to the formula, we need to square that value. So I'm just going to take that value and I'm going to square that. Plus cosine squared theta equals 1. Now you can use your calculator or you can use your brain. I'm going to use my brain. And I'm going to square my negative radical 2 over 5. Well, I know a negative times a negative is a positive. And radical 2, if I square that, is just a plain old 2. And 5, if I square that, is 25. Again, you can put that in your calculator. You'll get the same thing. Plus cosine squared theta equals 1. I'm going to just subtract that 2 over 25 over. Now you can do this in your calculator, or you can find yourself a common denominator and subtract there. That's up to you. But I would keep it in fraction form if I were you. So when I do that and I subtract, I'm going to end up with 23 over 25. Now that's cosine squared theta, but what they're asking you to find is cosine theta. So I'm going to take the square root and the square root. And I will get cosine theta equals the square root of 23, which doesn't break down, so I'm going to leave that. But the square root of 25 is 5. Now, you can put that in your calculator and get the same thing. Actually, I'm going to take that back. Ooh, I'm glad. We're going to talk about this. If you look at your 4 choices, all 4 choices are fractional answers here. Be very careful, because if I take the square root of this in my calculator, you're actually not going to get this value. You'll get a decimal equivalent, but that's not an exact value. And because I really want this to be written in fractional form, because I'm looking at my 4 choices here, okay, the calculator will not convert this decimal equivalent back to the square root of 23. So we tend not to use the calculator for some of this. So I simply just took the square root of 23, write it down, and take the square root of 25, write it down. Okay, and you can see that that answer then is choice 2. So I'm going to start off 35 much like I started off number 34, and I'm going to plug the value that they give me into the formula. And notice that they're asking me to determine an exact value of sine. I'll go back to that. So for right now then, I don't know what sine squared is, but I do know that cosine is negative 2/3, but I have to square that value, equals 1. So that's going to give me sine squared theta plus, okay, sorry for that. So negative 2 when I square that is 4, and 3 when I square that is 9, and that equals 1. So I'm going to subtract that 4/9 over. You can do that in your calculator or your head. You can find a common denominator. And so I have sine squared, and that's 9/9 minus 4/9, which is 5/9. Okay, I don't want sine squared though, I want sine, so I'm going to take the square root. That will cancel out my squared. And the square root of 5, which is just the square root of 5, over the square root of 9, which is 3. Okay, now, remember exact value. When I see that phrase, exact value, that means we want a fractional answer, which I have here. But here's an extra thing that wasn't in the last question. It does say that we are terminating in quadrant 3. So the reason why they gave you that information is, let's look at this. Quadrant 3, all students take calculus. And in quadrant 3, tangent is the only thing that's positive, and we have a sine value. So what we need to make sure that we do is we have to make sure that we negate that value. So then my answer is negative radical 5 over 3. So they gave us a cosine value. They gave us the Pythagorean identity. And again, I'm just going to plug that in. Now it does ask for tangent, which is a little bit different, but again, I will get back to that. They also talk about quadrant 4. I'll get back to that as well. So they tell us to use this formula, so I'm just going to start with that. So I have sine squared theta plus 7 over 25, that quantity is going to be squared, equals 1. So that gives me sine squared theta plus 49 over 625, right? 625 equals 1. Then I'm going to subtract over that 49 over 625. And that's going to give me sine squared theta. And that will give me 576 over 625. So then I'm going to take the square root of both sides. So I have sine theta equals, and the square root of 576 is 24, and the square root of 625 is 25. Okay, so there's my sine theta. Now, let's just talk about, though, the fact that they said that we are in quadrant 4. At this point, you should know quadrant 4 is cosine. So cosine is the only value, as well as its reciprocal trig function, secant. Those are the only two trig values that should be positive, and I don't have either of those. So I do want to make sure that I negate my sine value. So that's negative 24 over 25. Okay. The next issue that we have here is they didn't ask for sine, they asked for tangent. And you need to try to remember, and I'm just going to split this down so I don't get too messy looking, that the tangent is equivalent to sine over cosine. You remember that? So what I'm going to do is I'm going to replace, I do know what the sine value is, so I'm going to have tangent theta is equal to, here we go, my sine value, which I know is negative 24 over 25, and my cosine value, which they gave me to be 7 over 25. Now there's my tangent. Doesn't that look gorgeous? Not really. Okay, you can put that in your calculator as is. Just do a lot of alpha y equals, take it nice and slow, and you'll get a nice answer. However, I'm going to show you when you have a fraction here as a numerator and a fraction as the denominator, what we can do is something called keep, change, flip, and I don't know if you did learn this or not, but what you do is you take the denominator and multiply by the reciprocal. And what you do to the bottom, you would do to the top as well. So 25 over 7. And the reason why I'm doing this is if you look at what I'm doing, I am taking this denominator, and by keep, change, flipping, it's going to cancel out my 7s, and it's going to cancel out my 25s, and then I just have these two fractions up here multiplied together. Okay. Another way to look at it is I have negative 24 over 25 divided by 7 over 25. You should have learned that when you have a fraction divided by another fraction, that's the same thing as a fraction multiplied by its reciprocal. And that's what we did here. Okay, so this will cancel out, and then really what I now have is the tan theta equals negative 24 over 25 times positive 25 over 7. And then I can say, oh, well, those guys cancel out. So my tangent is negative 24 over 7. Now reminder, we're in the fourth quadrant. And in the fourth quadrant, cosine is the only thing that's positive. And its reciprocal trig function, which would be secant, which this is not. So we do have a negative value. You just want to double check that you don't drop that negative. So here's your answer. Anybody notice that this is the second number 36 on the page? The math teachers don't know how to count. All right, this is similar to the first number 36, so I'm just going to start by plugging in the cosine value. So I have sine squared theta plus, and then I've got negative 0.7, I'm squaring that, and that equals 1. So I've got sine squared theta. What do I have here? Plus 0.49 equals 1. I'm going to subtract over that 0.49. Oops, maybe I should write that decimal, huh? That'll disappear. You're going to subtract that. So I have sine squared theta, and that equals 0.51. Okay, so I need sine theta, so I'm going to take the square root of both sides. So I have sine theta equals 0.51. Or I should say the square root of 0.51. Okay, now this is why it's similar to the last one, because two things. First of all, it says that we are in quadrant 2. And remember, in quadrant 2, sine is positive. So let me just backtrack a second here. So that's good. I don't need a negative sign here because I'm in the second quadrant and sine is positive there. But the other reason why this is similar to the first number 36 is the fact that it's asking for tangent. So remember, tangent is the sine value over the cosine value. Right? So let me write that over here. So tan theta is equal to sine over cosine. Alrighty, so I know my sine value, right? That's a radical 0.51 over, and then my cosine value is negative 0.7. Doesn't that look gorgeous? Okay, so then you can put that into your calculator. Tan theta equals, and you should get negative 1.020204. All right, this one says to the nearest hundredth. Please don't forget, 2 is the hundredths place. Look to the right, that 0 is not bringing that up. So, in this case then, we've got tan theta equals negative 1.02. Now we are in the second quadrant. Tangent is negative. We are all good. There's our answer. Okay, so let's look at number 37. This was a Regents question. I remember a lot of kids got this wrong, and it's actually really very easy. I want you to look at the fact that what they gave you here, right, doesn't that kind of mimic what we have right down here, the Pythagorean identity? So do you see that 32 is my value for theta? And they're asking, then what is m? Well, listen, if theta here is 32, shouldn't this theta also be 32? Because that theta and that theta should be the same value. So if this theta got replaced with 32 here, then this theta should get replaced with 32 there, which means m has to be 32. Answer's choice 1. I know I haven't said this in a while, but please make sure everything that is in this video you are writing down on your packet in your notes. Okay, if you don't have a packet, you're putting it on loose leaf. All right, so if we look at 38, you see that I wrote the Pythagorean identity. You're going to have to commit that to memory, by the way, but it's pretty easy. Now they give you point m, and they tell you that the x value is t, and the y value is 4 over 7. Do you remember that the x value, we associate that with cosine, and the y value we associate with sine? So I can just plug these values in for sine and cosine respectively. So my sine value, I know, then is 4 over 7. So I'm going to put 4 over 7 here. Of course, I'm going to square that though. Plus, now I don't know what my cosine value is. So I do know that it corresponds with the x value, which is t, right? So I'm going to leave this as cosine squared theta equals 1. All right, so I have 16 over 49 plus cosine squared theta equals 1. I'm going to subtract over 16 over 49. You can either find a common denominator and do this in your head, or you can put it in your calculator. So cosine squared theta equals 33 over 49. And I'm going to take the square root of that. See, so that gives me cosine theta equals the square root of 33 over 7. All right, let's think about that for a second. Remember that I said up here that cosine we associate with the x value, which is t. And isn't that what they're asking you to find right here? They want you to find the exact value of t. So this really is your value of t. Now, the next thing I want to point out, though, is they told us that we were in the second quadrant. Second quadrant, sine is the only thing that's positive, and I don't have sine. So make sure that you put a negative with that radical 33 over 7. Final answer is negative radical 33 over 7. I wrote down the Pythagorean identity. They give us that the cosine is negative 3 over 4. Sine squared theta plus negative 3 over 4. Remember to square that, equals 1. Sine squared theta plus negative 3 when I square that is 9. 4 when I square that is 16, equals 1. I'm going to subtract that 9 over 16. You can either find a common denominator and subtract, or you can use your calculator. That'll give me sine squared theta equals, what is that, 7, right, over 16? But that's sine squared. I want sine, so I am going to take the square root. Sine theta equals the square root of 7, and the square root of 16 is just a 4. All right, so let's read the question one more time. It does ask for sine theta, which is what I have, but here's the thing that I want to be careful of. I'm in quadrant 3. So quadrant 3, let me just write this down for you. Remember, quadrant 3, all students take calculus. Quadrant 3, tangent is what's positive, and its reciprocal trig function, which is cotangent. I don't have that. I want to make sure that I put a negative then in my answer. So there's my answer, and that would be choice 1, correct? There we go.